Who doesn't like breaking into a Java web application? Well, probably not if it's your application and you own it, or your boss, your employer, or whatsoever. But before we go into the hacking, we need to talk about this word, DevSecOps. And the first time I saw this word, I felt like, come on, this is yet another buzzword. Just put blockchain and machine learning in the mix, and we have full buzzword bingo. However, if you look at the word, it is kind of interesting as how it evolved. Because first we had DevOps, and you probably all know of DevOps, do DevOps, or, well, maybe you're not even aware of that. Because think about it. If you are developing software and nowadays you are responsible for the whole shebang. So to some extent, putting it into production. And if something goes wrong, it comes back to you. You need to fix it and bring it back to production. If that is to some extent even automated the case, then, my friends, you are doing DevOps. You own what you create. We basically tried to tear down the wall between the developers and the operations folks. One thing we didn't yet do was having security in that same mindset. I mean, we think about scalability, modularity, and making sure your code looks pretty. But how much do we take care of security by design and by creation? Not yet so much, because security is still siloed at the end. We are going to take care of that, and I will show you why we need to adapt and adopt this mindset to be secure from the beginning. But first, this is me. I'm doing a lot of stuff. My name is Brian Vermeer. I live in the Netherlands, and I am a developer advocate for Sneak. I'm a Java champion, yada, yada. I do some stuff in the community, yada, yada. Not really interesting, because we're trying to solve a problem here. We're trying to solve a problem with that DevSecOps mindset. But what is that actual problem? Let me take you into a personal journey. That journey started about, say, a decade ago, 10 years or something. And I worked at a government agency here in the Netherlands. And you know, government agencies and banks and insurance companies are quite conservative. At that point in time, and that was about 10 years ago, we deployed about 3 times a year. If we fast forward to nowadays, that is, you cannot think of that anymore. 3 times a year is perfect, because then you have enough time to test. And if you already worked, well, we work in kind of sprints at that point. And then we created a dedicated sprint to create a release version that we could fully test before going into production. And, well, we weren't really DevOps, so we just threw it over the wall to the ops folks. They made sure that it was in production. Cool. Fast forwarding to today. And especially, for instance, in e-commerce, we deploy heavily. We deploy far more, maybe 3 times a day instead of 3 times a year. And is it still feasible to work the way you work? I mean, because I'm doing 3 times, we did 3 times a year, there was enough time to do a pen test or something like that. With 3 times a day, that is practically impossible. So that means we have to shift that mindset. The point, however, is we still are focused on creating software in such a way that we think about problems and features. I know that person that is a product manager breathing down my neck, we want this feature today, release it. But security is not yet something that I learned in school, at university, or I'm not aware of, like maybe some things, but not all. And actually, I am a builder. And we have the security team to do that, right? However, just like we had dev and ops siloed, security is still a siloed thing for many companies. At the end, so after my 3-week sprint, there is this person in the security team that says to me, sorry, dude, we found an issue. And that is like, okay, I can cope with that 1 time. But 2 times or 3 times or every sprint, I'm like, come on, think with me, help me out. But that is the problem of being siloed. At 3 weeks, somebody might take a look at that, say, nope, and there is friction between the development team or the DevOps team and security. And we need to get rid of that, because in the end, we're all at the same team. We're all part of the same team, and we do not want that our customer data is compromised, or that we are that next big headline in the news that, hey, you leaked a bunch of names or personal identifiable data. It's not what you want. But how bad is that situation? Well, let me take you into a story here that was back already 4 years ago, 2017. And maybe you've heard of it. It's a company called Equifax. It was an American company. And it's a crediting company. And crediting scores in the US are very, very important because, well, it basically says, can I get a mortgage or can I get a loan, or how creditable how much credit can I get? Anyway, this company, I'm not actually going into the company problem. I'm going into the actual breach. So what the folks at Equifax did, they built an application on top of, at that point, Apache Struts 2. That sounded interesting because the point is there was an issue with Apache Struts 2. At that point in time, there was a vulnerability found and disclosed, and there was already a newer version available. But what do we normally do is we focus at our business value, at our business logic that we build on top of that framework. So I just assume here that with our business logic was nothing wrong. But because they were using that framework, which is basically the foundation of your application, people could get in, snoop around for months, literally months. And in the end, over 140 million customers were compromised. Little timeline. I think it was March 2017. This breach was already found in this specific version, and there was a patch released. The problem started in May of that year. So that's already a few months later. This existed for over 70 days until the company noticed there was something wrong. And at this point in time, the damage was already over $2 billion US. And that is a lot. But let's get into the hack. I promised you some live hacking. So let me show you an application. I'm showing you an application over here. And I'm not even going into the application because this application contains that same Apache Struts 2 version. And it runs on Heroku just to spice it up. Just I have to make sure that it still runs because, hey, if I'm not doing something for an amount of time, it will spin down, and now it needs to spin up. But let's get into the hack first. What's happening? Well, what I can do, I can create a curl request, and I can create a curl request with a specific content type. And that content type is what you see here on my screen. And you're like, yeah, that's a header. That's the content type, but I don't recognize the value. This is the value. Sure, because it's an invalid content type. And with that invalid content type, there's something happening. Because it is invalid, you go with this specific version of Apache Struts 2, you go into an exceptional flow. And in that exceptional flow, for some reason, you are allowed to utilize OGNL. And that's the Object Graph Navigational Language, basically the expression language within Apache Struts. With that expression language, we can do a bunch of things. We can call certain methods on objects, but we can also introduce or create new objects. So we can call getters and setters. That's nice. But creating the new object, that is the bad thing, because what I'm doing here is I am creating a new process builder. And I'm feeding this process builder basically the terminal, the bash. And if I can feed that bash any arbitrary command, hopefully I can execute a bunch of things that you don't want me to execute. What I do more is I get the output stream, reroute to the input stream to make sure that it is actually visible over here. So let me check if this one is running. Yes, it loads. Cool, it's running. So I don't need to go into any application. I just stay in my terminal like a real hacker. And then I have to put my hoodie on, but then nobody can hear me anymore. Nevertheless, so I'm using this header, and let's say, what shall we do? Oh, yeah, I love this one. We will get the environment variables. And I will just explain it to you in a second what I'm doing here. I'm using that header I showed you. And I am substituting the word command for the word env. You see? And then I'm not launching it at localhost because this one is not running on localhost. No, let's go to Heroku. So what I'm actually doing is env is just a command on the Linux machine that shows me the environment variables. And with this header, just giving it this application or doing this curl request with this header, let's see what happens. And you see what I have here at this point? Here. These are partially the environment variables of my Heroku machine, of that specific Heroku pod that is now running in the cloud. And then you say, yeah, but the environment variables, how interesting is that? Not really. But if I can call the environment variables, I can probably also create a file with some content, create a script. And that script does all sorts of nasty things. And if I have the right privileges, maybe I'm able to delete a few things, to create a few things, to get into a database, scoop some data. Basically, I have a free pass. I can execute code on your machine and you're not even aware of this. And even though this is not the full output of the environment variables, because, hey, something with buffers, it's still executed. And that's the most important part, because I can execute it in a separate thread. So, okay, at this point, I have the environment variables. And one thing that's interesting over here is that I know where the Java home is, /app/.jdk. And I will need that later on in another hack. So keep that one in mind and bear with me. But let's get back to my slide deck. So we talked about Apache Struts and what the problem is over there. And that is nasty. I mean, people were not really aware of this. So let's translate this to your own application. Say this is the jar or the war, or maybe even old-fashioned an air file that you put into production. How much of the code that you put into production is actually yours, the thing that you have written? It's probably something like this. Not that much. You know why? Because we all base our application on frameworks, libraries, more libraries. And we know that if you put in a framework, that puts in another library, and it goes several layers deep. The majority of our code, approximately 80 to 90%, is not yours. It's something that we borrow from the internet or Maven Central or whatever you get your jars from. And that's for a good reason, because we do not want to create yet another CRUD repository or yet another REST endpoint, or we don't want to redo things that are boilerplate. We want to do the stuff that makes us valuable, and that's creating business logic. However, let's put some numbers to this, because this is a JavaScript application that we created, a serverless application to store some files in the S3 bucket. And it was 19 lines of code. And we did this already like 2 years ago. But the numbers are interesting because it had 2 direct dependencies. And we know a dependency brings in another dependency, brings in another, and that goes several layers deep. It doesn't matter in what ecosystem you are. It's basically the same in every ecosystem. So 2 direct dependencies. And just take a number in your mind. How many dependencies do I have in total? Well, you probably think it's a lot because it's Node.js, so NPM. But it was just 19, which is fair. Now the $1 million question is, how many lines of code do I actually put into production? Because everything that is there is part of the stuff that I'm responsible for. At that point in time, and that's about 2 years ago, it is almost 200,000 lines of code. And that makes it interesting because in this case, 19 lines of code is not even 1% of what I'm putting into production. But I'm responsible for all of it. And then people say, yeah, but not every line of code is executable. But think about this. There are not many security issues that were a direct hit. Like, hey, we have got a problem over here and we directly connect to that and then poof. It's probably a chain of problems connecting to one object or to one library that connects something else to something else to something else to something else. And then finally in that chain, we have a sink, as we call it, and that is actually executing the painful payload. That is typically how things work. But let's go into Java because that is even more interesting. Java Spring serverless application. And this is just a snippet of the code because it was 222 lines of really awful code because it was a demo application. Lots of duplication, but still. It had 5 direct dependencies. And now you can already see that's the Spring Framework Cloud something, Spring Data something, and some AWS stuff. 5 direct dependencies became 54 dependencies in total. How many lines of code do I put into production? It's almost 500,000 lines of code, over 400,000 lines of code. And think about it. If you think about Java, then every jar that you have and that's available in your class path can be technically loaded into memory because it's available to you. It might not be there yet, but it's available to you. So if I can do an arbitrary code execution like I did with the expression language and struts, I can leverage that to do some other things, to do some nasty things, and poof, you get me? And do you know what you're actually putting into your application? Because we know that open source usage has exploded, and that's for a good reason. And I love open source, and I'm an open source contributor myself. But we do take good care of our own code. The code, that middle piece, that middle small circle, we probably have code reviews and maybe even pair programming in place to make sure that that code is well maintained, well written, fully executable, fast, modular, whatever it is. We're proud people, developers, specifically Java developers. We make good code, but how about the stuff that we include implicitly? I mean, that is just as well written as our own code. Basically, we import that blindly. However, our own code, we make sure that at least 2 or 3 people looked at it before we put it into our master branch or even in production. So we should take care of that part of the software as well. Because think about it. If there is a library that is well used, well maintained, but it has a large amount of users because, hey, it's well known. And there is a problem there because people will snoop around. It's open source, right? There are potentially a lot of victims. So one thing that you should consider is, what is my update strategy? Do I know what I put in? Do I actually need it? And do I want it? All questions that I cannot answer for you, but depending on your context, you should answer that yourself with your team. Because we saw that over the last couple of years, the amount of new packages by ecosystem have increased every single year on top of what we have. And that's logical. But NPM over here is the clear winner. During 2019, I think they were over, I think it was mid-2019, mid-2019, they were at that mark of 1 million packages. And thinking from that perspective, you can say, well, there's a lot of crap in that, but you can also see it from, there is a lot of variety in that. And if you look at that, you need to make a pick. If I want to solve a problem, what package do I pick to help me for that? And is this package good enough? Or do I need to pick another one? How secure is this package? And even for Maven, even though the amount of new packages in 2019 was quite large, in 2018, it was quite big, but it's on top of what is already there. And what we see here is that the vulnerabilities identified each year for each ecosystem, and we took Maven Central as one of the benchmarks, you see that we're the clear winner, unfortunately. And although it's little less than 2018, it's on top of what's already existing. And the fun part is, if you look at a single POM file and you look at the packages, it might just be 3 or 5 packages. But most of the problems are not in that package that you declared in your manifest file, but in the stuff that's underneath it. If you bring in a Spring Boot starter, do you know what you're actually bringing in? Many times it's just an empty jar file, including a POM, having a POM file that brings in a bunch of other stuff. So a starter like that brings in a ton of other jars, and you are probably not aware that you're bringing this in. And that is okay to the extent of, if it works and it's fast, okay. But is it safe? Because we asked open source maintainers how confident they are in their own security knowledge. And 63%, sorry, says, kinda. And how much do you trust? Well, kinda. I'm okay-ish. But we do not trust each other, and we need to review our code. That's counterintuitive to me. And then we can argue about who is actually responsible for security, because, hey, I'm a developer. And we asked that in our State of Open Source Security 2020 to ask that to all sorts of people, developers, security folks, operations folks, general maintainers of open source packages. And this was the conclusion. If we think about software, and that's just the application, then developers definitely need to take their fair share. But on top of that, there's also things like infrastructure. For instance, how do I connect my Docker containers? How do I build up my Kubernetes files? And in many cases, that's another way of attacking an application. But if we look at software, it's quite obvious that we as developers need to take our fair share in that security mindset, because I make the decision that I want to solve a certain problem with my code and maybe a library that I pull in. So if I pull this in, I do consider if it's machine heavy or memory heavy, but how about security? That's also a thing that we need to take into account, because we take that decision. We have the liberty, and hopefully you are an autonomous team, but then we need to like own it all and not just, hey, if it works, ship it. We also asked people like, how do you find out about vulnerabilities? And unfortunately, 27% says, I probably won't, which is kind of scary if you look at that from a worldwide perspective. But you've probably worked in IT for a while, and even not, but you can imagine that in some cases you work with applications that are there in your production environment for years and nobody dares to touch it anymore, like these legacy applications still running on Java 6 or something. I will assume that at that point in time that they were launched, they were vulnerability free. But in general, it takes a lot of time to find a vulnerability and to disclose it properly and to get a fix out. How much time does it take in general? Like, what is the median? The median in this case, after our research, was 2.5 years. So if you have something in production and it's been there for a while, without doing anything, there probably are mistakes in that can be exploited, utilized. So if it's outward facing and mission critical, or either of these to some extent, you might want to take a look at it. I already talked a bit about Docker containers, a small bit, because Docker containers is another way, because we have the application and now we want to provide it the environment. And what do we do with a Docker container? Well, we want to place our application in it. But the first thing you do when you build a Docker container is writing something like from Ubuntu or from Maven 3, or you base your stuff on top of a base image. Late 2019, I did a research on the 10 most commonly free downloadable base images. So base images from Docker Hub, I downloaded them. They were totally free, and I scanned them for problems. And this was the result. All 10 of them had issues, security issues. And the Node.js one was the one with the biggest issues. However, these were the latest image, so not a specific tag. And then you have to think of, hey, how does this work? This Node.js image, for instance, is built on top of a full-blown Debian operating system. And do I need a full-blown operating system for my tiny microservice? Probably not. Because that full-blown operating system brings in a bunch of extra programs and binaries that can be helpful, like are to some extent dangerous, if you put them in the right chain. And these are all vulnerabilities that are known. These are known and published. So if I know them, if I can scan them with my software, the bad people know them as well. So thinking about this was not specifically a node problem or whatever. It was the problem of the operating system. And that is another factor that we need to take into account. What do I actually pull in? Hey, if it looks stupid, but it works, it can still be vulnerable. We asked people, how do you scan your Docker images for operating system vulnerabilities? And a lot of people say, we won't. And then we asked them, how do you find out about these vulnerabilities when you already deployed a container? And probably over 40% says, 45% in this case says, we probably won't. So even though my application can be perfectly fine, it can be that I have another attack that I'm just attacking your environment. Hey, nice. And then I can combine the two. But let's go into hacking and let's stick into applications. And let's first make a little bit of fun of Node.js because we can, and I will set the tone. And after that, I will go into Java, trust me. So I have an application over here, and I will let me enlarge this a little bit so you can actually see it. It's a to-do application, and I can say something like buy flowers, and I can spin up all these to-dos. Awesome. But what I can do as well, at the bottom over here, you see a link about, and that is to the most modest about page ever. You see, very modest. And you know, I'm a great UX designer because it is scalable. I mean, if I do this on mobile, Perfectly works, right? Contrast levels are fine. Black and white, always readable. But that's not the point. The point here is I'm serving this to you using a NPM package, the ST library. And the ST library has a problem. And I will show you what the problem is because it's a path traversal problem. So just like before, I'm going into the terminal. And what I'm going to do is I'm going to curl this application. So just saying curl /public/about.html. And if I do that, I will get the HTML right away. Amazing. So I said there is a path traversal problem. So the first thing I want to try is going all the way out of the public folder, out of the web server, maybe all the way up to the root of the system. Because if I do .. in the root, I will end up in the root anyway. So let's try this. But what happens, I get redirected back to my homepage because over here you can probably recognize this is just the link to the about page. What we knew and what we saw is that this is not so much a real good way of filtering because it specifically blocks the .. So good side. The folks that created this already had some security in their mindset, like, hey, we need to block this because path traversal is a nasty thing. But by specifically blocking the .. we can, well, circumvent it, make sure that it doesn't happen, or not try another way. Be smart in this one. And one thing that we can do is, well, people suggested once to me, like, maybe you can do something like escaping, or trust me, that doesn't work. Look, doesn't work. But what does work is URL encoding. And now, $1 million question, what is the URL encoding for a dot? Nice question for your next interview if you hire a new junior or a new person on your team. It's %2e. If the person knows that, then he probably tried this one before. That says something about somebody. So %2e, that's basically the equivalent of .. And if I do this like a trillion times, doesn't matter how many times, well, at least enough times to get into the root, like this. And then you see this is the root of my local system. And think about it. Yeah, you might say you don't need to run this application as root. Absolutely true. But do you know how you run a Docker container by default? If you run a Docker container by default, you are by default running it as root. Again, a connection of two problems being vulnerable. So, okay, I can go into the root, so I can maybe go into the passwd file and read what the content is of there. If I can do this, I might be able to do this in other files as well. And that is not a big problem. You might say like, hey, you can only read, who cares? Well, if I can read the property files of your application that maybe contains a token, then it's interesting. If I have clues that help me to create my next attack, then it's actually helpful. It's a start of a journey. So what I can do as well, say it's not an open source application. It is, but hey, just pretend. And I'm just doing this once, %2e, %2e. Then I see this as a JavaScript application. Amazing. I didn't know before. Let's go into the package.json, which is, well, pretty much your manifest file like your pom.xml. And I can see what kind of libraries you are using. I'm seeing you're using DMS library, and I'm seeing you do the Mark library, and I know that all of these libraries are vulnerable. All right. So we have seen path traversal, and this is a problem in this application. There are far more problems because we created this application to demonstrate these kind of issues. And that's because we didn't put in the right version. If I would have scanned this with the proper software, you could have known this and you could have updated to a newer version. You were not vulnerable for this application or for this exploit anymore. And that is the whole point. But let's get into the Java application, shall we? We have that Java application I showed you and the one with the struts exploit. Let's get into that application. So I will sign up for it and I will say, hey, let's sign up with my name and my email address and give it a password. 6 characters, 1, 2, 3, 4, 5, 6. Because I work at a security company and this is perfectly safe. No, but hey, it's a demo. So sign up, I'm here. No, don't put it in my password manager. Again, it's a to-do list, but I can do funny things with it. I can do something like this. I say eat pie with a nerdy pie sign. Put it somewhere at 9070 and oh wow, it's already 4:30. So I probably am hungry. I didn't have lunch. So give it a high priority. And if I do this, you will see that the application shows me the to-do. But the pie sign, and I'll enlarge it a little bit more, the pie sign is transformed into the ASCII representation. And I know for a fact that the title goes to the native to ASCII function, which is part of the JDK. It's a function that is there for you. So you put in the symbol and it gives you the ASCII representation. Interesting. You know what we can do as well? We can upload files. We can upload zip files. And if I upload a zip file, it will unzip my files. And you will see at this point, there's no file unzipped in it. Okay, so we now have a bunch of information. Let's connect the dots. So we already knew what the environment variables were. We knew where the Java home is, and we can upload zip files. But what if my zip file looks like this? In this zip file, there are two files. The first line is a regular good.txt. Amazing. Works perfectly fine. The second one is a .. all the way up to the root of the system /app/.jdk, which is the Java home of my Heroku application. And I know that my native to ASCII function is in the /bin file. Now I can show you what's in the native to ASCII file. It's literally echo and it says something. But what I'm trying to do here is I'm trying to unzip it and I'm trying to do a path reversal all the way back to the path and overwrite the native to ASCII function in my application. And you know why? Because I'm using a library to do the unzip for me. We don't have an unzip version of an unzip function in Java. We can inspect the zip entries. We can get the byte stream out, but we need to recreate the file and get that byte stream from that zip entry in it. So I'm using a library for that. So let's do this. So let me upload the file. Over here somewhere. Let me check. Exploits zip slip.zip. Cool. So I'm uploading the zip file I just showed you. And let's see. Now in my files, I see that in the public folder is the good.txt, the one that I expected. So I know for a fact that the unzipping took place. It executed. But what happened to the other file? Well, let's create a to-do. And let's say, hello, JDD, folks. Oh, folks. And it doesn't matter what kind of date I put in because that's not important. Also, the priority is not important because now this will be translated to muhahaha gotcha because I've overwritten the native to ASCII file in the JDK for this instance. And if I put in something else, doesn't matter what, and I give it a date somewhere, doesn't matter. Again, every entry will now be, because it goes through that native to ASCII file, will be muhahaha gotcha. And again, this is just to make fun of it. But you see that there's improper validation of the input of the name of the zip entry that we're using. And it doesn't filter out the .. But if I knew that this version of this library was there, it is already solved. A newer version is already in place for years. But I didn't notice because I was too busy working on new features of this application instead of looking what is already there. And I never noticed. Even if I do it today, this version is still available, of course. So let's wrap up. Oh, the application is there. So I showed you some hacks, but how can we solve all of this? Well, we need to solve three things: culture, process, and tooling. First of all, let's talk about culture. And I say team culture, but it can be company culture. We work with different people. Developers think about different things than security folks. And well, as developers, I want to create things, make sure that the code works and it's fast. But the security folks just want to make sure that things are safe. And that might collide. And if you look at management, for instance, they think about, hey, making profit and making sure that that feature is out today. But if management doesn't give me time to fix my technical debt, bugs will slip in and might be security issues. But if I'm not security aware and develop in such a way that I'm saying, hey, if it works, fine, I ship it, then in the end, with that higher delivery speed, that 3 times a day, security teams cannot keep up with it anymore. So we need to think in each other's lines, because at the end, we're at the same team. And it starts with that. If that is not there, if people are not convinced doing that, then the rest is useless. Then we need to think about process, because naturally we're enforced to like put in more process. No, if I just put in more process, it might work if you just got breached and you're keen on it from that moment. But if not, then it just works against you because you're used to a way of working. So look at the way you work now and see how we can integrate new practices like scanning your application, or making sure that you are aware of who reviews my code. Like if it's something is security heavy, do I give it to my junior, or do I give it to somebody who's a bit known in security in my team? It's still a review. You got me? Put in the right tooling that fits your process. Saying, for instance, you don't have a CI pipeline. Hopefully that's not the case, but say that that's the case. It doesn't make sense to say automate it in your CI, and then you say, I don't have a CI. Doesn't work, because you're not used to the way it works, and that you will not. There will be no adoption in your company. So that's why I come to tooling. Pick the tooling that fits your process. For instance, say you are a person that likes to work on the terminal. Why not have a tool in the terminal that can scan your application for you? And of course, my company provides such tooling. But the point is, you need to do the scanning of your application or the tooling. You have to provide it in every single line of your software development lifecycle. So while you're coding on your local machine, for instance, scan your application with the plugins in your IntelliJ or your Eclipse. Connect your GitHub repository to an application that scans for you to show you if there are mistakes in it. Because, hey, if a new branch comes in or a new pull request comes in, you want to scan not to get worse. Maybe a bit better, but at least not worse, right? You don't want to bring in new problems. And again, your CI pipeline, if you have that, that's a perfect way of scanning it automated. Absolutely fine. But you're not done. Because once you go to production, you need to make sure that you take that snapshot of what's happening at that point, for instance, your dependency tree and your code, and scan it over and over again on a daily basis if no new problems are found. Because the combination of your code and your libraries that you pull in, they can be harmful. So let me show you one more thing. If I go to, and again, I'm using the free version of my own tooling just to show you that all these things that we have here are actually deliverables that we could have prevented. See, if I go to my Java goof and I say the struts application, this is the POM file, and already see here that Apache Struts 2 has an issue. And if I look in the details, it will say something about the content type. And it will tell me, because I connected my GitHub repository to this, that if I upgrade to a newer version, it would already be gone. But you can do that in different ways, in different parts of your software development lifecycle. And you need to do that basically in all of these things. And then we say you need to shift left, as in as early in the process as possible. So from your local machine, before I commit to my main branch or master branch. But it's a continuous process. So there is no shift left, basically, because software development is never done. We keep continuing the process, or at a certain point, we rewrite it. So it needs to be done in every single pillar of your software development lifecycle, in my opinion. Also, when you are in production. If you want to know more about best practices, we wrote a bunch of stuff like how to create secure Docker containers and how to have security best practices in your Java application. It's on our blog. I actively contribute to that, so feel free to go over there. And if you have any questions, feel free to ask them now, or to ping me either by email or on Twitter. And I hope you enjoyed this. Back to the studio.